In permutation and combination, we are looking at the miscellaneous examples now. So we have a word called involute. The question is how many words with or without meaning, each with three vowels and two consonants. Three vowels and two consonants. We are aware that the vowels are A, E, I, O, U. These are all vowels. So let us see how many vowels are in involute. So there are four vowels. I, O, E, U. If you find it out, it will be 4. And we have another left which are known as consonants. So we have to choose 3 vowels. So there are 4 available and we have to choose 3. So 4C3 is the number of ways of selecting 3 vowels from 4. In the similar fashion, how to select the consonants from this, because 4 consonants are available. So 4C2 is the way. So 4 and 6. Now the number of combination of these 3 vowel and 2 consonants are nothing but 4 into 6. 4 into 6. This is equal to 24. So each of these 24 combinations, they have now 5 letters. So they are 5 letters and these can also be arranged in factorial 5 ways. So 24 into factorial 5, that is 2880 will be the answer. Next is a group of girls consisting of 4 girls and 7 boys. The group has 7 boys and 4 girls. Now you have to make a team of 5 members. So you have to select 5 members, and in this scenario, first there should be no girl. That means you have to select all from boys. 7 boys are there. You have to select all 5 from this. So 75. This will be your answer. So the team is not going to include any number, and the boys are to be selected. So 5 boys out of 7 boys are to be selected. 75. Next is at least 1 boy and 1 girl. At least 1 boy and 1 girl. That means 1 boy or 4 girls, 2 boy or 3 girls, 3 boy or 2 girls, or 4 boys or 1 girl. So this is possible. These all scenarios are possible. So choosing 1 from 7 is 7C1 and 4 from 4 is 4C4. Like this all you can do. So just multiply these and add them. This will be your answer. That will be 441. Now at least 3 girls. That means 3 girls. At least means it cannot be lower than 3 girls. So 3 girls, or you can have 4 girls. So if you have 3 girls, you need to take 2 boys now, and if you have 4 girls, you need to take 1 boy. Now just 3 girls and 2 boys. So 4C3, 7C2. Multiply them. 4C4 and 7C1. Multiply them and just add them. So these two, and add them. Next is example 22. You have to make the number of words with or without meaning that can be used or that can be made using all the letters of word again. So if these words are written in a dictionary, what will be the 50th word? Again means there are 5 letters. So we have factorial 5 ways to arrange. But A and A, it repeats. So you have to use this factorial 2 as the denominators. Factorial 5 by factorial 2, this is actually the required number of words. Now, if you want to find out in the dictionary scenario, for that, first assume that you have A here, fixed position, and then others. These other 4 can be arranged. So A is fixed, so you have factorial 4 means 4 letters are there. You can arrange it in the factorial 4 way. But you see, when you fix this A, okay, you do this 24 ways. Now when you fix the next one, which is alphabetical in this, is G. So you fix G as the first place and next 4 place. So G, when you are fixing, A can be anywhere here. Okay. Now A can be arranged. So this is factorial 4 by. Now A is repeated. So factorial 4 by factorial 2. Similar case, if you take I as the first one and fix it here, then the total number will be again 12. So 24 plus 12 plus 12, which is 48. So 48th term, if you take 48th term or 49th term, it will be NAAGI, and next one will be NAAIG. 50th one will be NAAIG. This we have found out using the dictionary version. How many numbers greater than this much? This is actually 10 to the power 6. So how many numbers greater than 10 to the power 6 can be found by using these digits? So in all there are 7 digits. In all there are 7 digits. 1, 2, 3, 4, 5, 6, 7. But the thing is, in these 7 digits, the starting one, the one digit is 0 also. So there are two methods. This is an alternative method, but first we'll see the first method. That is, if the number starts with say 1, then you can take 2 also, and you can take 4 also. So 1, 2, 4. You cannot take 0. 1, 2, 4. So if it starts with 1, then others because 6 places are remaining. So factorial 6, and we have because you have started with 2, 1. You have fixed 1. So 2 are 2 times, 4 are 2 times. So factorial is 2 are 3 times. 1, 2, 3. So factorial 3 or factorial 2. Now just fix the first one with 2. Now you are just left with with 2 2's and 2 4's. So say factorial 6 by factorial 2, factorial 2. Next is you fix 4 on the first position, then you are left with 6 position. And here when you fix 4, you have 3 4's, right? So you 3 2's, because 1 4 you have used, 1 4 will not create any problem here. But 3 2's, they can be arranged in factorial 3 ways. So it will be 120. So add 180, 120 and 60, you'll get the answer. The next thing is, alternative is to find all the arrangement which are possible. That is 7 positions are there, factorial 7, and these are number of 2's and these are number of 4's. So factorial 3 by factorial 2. But here we have also accompanied or counted the 0 which may be in the first position. Okay, 0. So we have to remove this from computed value. What we'll do is factorial 6 by factorial 3 factorial 2, because we have fixed the first position as 0, so we are left with 6 positions. So 6 and 3 and 2 will also remain. So 60. 420 minus 60, because you have to remove those which have the 0 as the startup. Then just subtract it, you'll get the answer. So in how many ways can 5 girls and 3 boys be seated in a row so that no two boys are together? So these are 5 girls sitting, and these are only the possible positions of boys that can be given. So 5 girls, easily 5 factorial. How about boys? There are 6 positions. 1, 2, 3, 4, 5, 6. 6 positions. And only 3 boys needs to be chosen. So factorial 5 means 3 boys can be arranged in 6 position in this way. 6p3. This is arrangement. Factorial 5 are girls, 6p3 are boys. This is your answer. So let us summarize. How to summarize that? This is the fundamental principle of counting. That means if something happens in M, the next one is coming in N, next one is coming in P. So all of these occurring is M into N into P. The number of permutation of N different things taken R at a time. So you have these N, and you take this R. Okay, so you are taking R at a time and different things where repetition is not allowed. So it is denoted by NPR, which is given by NPR is equal to factorial N by factorial N minus R. Factorial N is nothing but 1 to N, and factorial N is N factorial N minus 1. You can also write this as N minus 1 factorial N minus 2, and likewise. Next is the number of permutation of N different things taken R at a time is actually N to the power R if repetition is allowed. Then the number of permutation of N objects taken all at a time, where this repetition is, where we have indistinguishable objects of same kind, you can say, it will be equal to factorial N by number of times these are repeated. And then we came across NCR. NCR is nothing but factorial N by factorial R factorial N minus R, right? So this was all about the permutation and combination. Thank you so much. Take care of yourself.